We are grateful because we managed to complete this video presentation within the time given by our lecturer, Dr. Wan Munirah. This assignment is impossible to be done without the amazing cooperation and effort of our group members, Uzair, Danish, Zarfan and Shahrid. We also sincerely thank our lecturer of calculus, Dr. Wan Munirah, for the guidance to help us in this semester and this assignment. Application of differentiation in economics.
What is differentiation?
In calculus, differentiation is one of the two important concepts apart from integration. Differentiation is a method of finding the derivative of a function. Differentiation is a process in math where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate change of displacement with respect to time called velocity. The opposite of finding a derivative is anti-differentiation. If x is a variable and y is another variable, then the rate of change of x with respect to y is given by dy over dx. This is the general expression of derivative of a function and is represented as f prime x equal to dy over dx, where y equal to fx is any function.
What is differentiation in economics?
Economics and business. In economics, the concept of derivative plays a very important role in decision making. The marginal functions used in economics that is defined as the change of one variable with respect to another variable uses the concept of derivative. Many economic models are constructed in continuous time and use the time derivative. For example, the economic cycle or business cycle or trade cycle represents a wave of the gross domestic product (GDP). The fluctuations mean a change and the rate of change is measured using the concept of derivative.
What is applied maximum and minimum? The process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost, or find the least amount of material to make a particular object.
Problem statement. Company produces and sells a product, and the profit Px it earns depends on the number of units sold, x. Suppose the profit function is given by Px equal to negative 2x squared plus 40x minus 100, where x is the number of units sold, Px is the profit in dollars. What we want to find is the number of units to sell to maximize the profit and the maximum profit.
And how to solve?
Step 1. Find the critical points. Take the derivative of Px to find where the slope is 0. P prime x equal negative 4x plus 40. Set P prime x equal 0. Negative 4x plus 40 equal 0. And x equal 10. Step 2. Determine if it's a maximum. Use the second derivative test. P double prime x equal negative 4. Since P double prime x equal negative 4 less than 0, the function is concave down at x equal 10, so x equal 10 is a maximum.
Step 3. Find the maximum profit. Substitute x equal to 10 into the profit function. P in bracket 10 equal to negative 2 times 10 to the power of 2 plus 40 times 10 minus 100. P in the bracket 10 equal to negative 200 plus 400 minus 100 equal to 100.
The answer is the company should sell 10 units to maximize the profit. Second answer, the maximum profit is $100. Conclusion, the analysis of the profit function demonstrates the practical application of calculus in economics, specifically in optimizing business operation. By identifying the number of units that maximize profit, companies can make informed decisions to allocate resources efficiently, ensuring maximum profitability. This process highlights the importance of understanding the relationship between production levels and financial outcomes, enabling businesses to strategically plan for sustainable growth and competitive advantage.